Okay, so the purpose of this activity that we're going to be doing is basically just to get a bit of a break from sitting down and doing vector component addition problems for hours on end, because that gets pretty boring after, 2. So we'll look at doing something else for a little while here. Okay, this map activity, which still makes us do some vector component stuff, okay, and doing some v equals d over t review and things like that. Okay, but at least gets you working with some other people for a while. So how many people have used a topographical map before? Yeah, Google Maps has ruined an entire generation of children. Yeah, satellite locating and all that. It's a topographical map. That's exactly, what's a topographical map? A bunch of you are probably thinking, maybe I have, but I don't know because I don't know what that is. If you don't know what it is, you haven't used one. So a topographical map looks like this, okay? And it's got lines, lots of these little curvy lines on it. Okay, the little curvy lines are actually there to make a 2-dimensional representation of a 3-dimensional space. So the little curvy lines follow the topography, or the surface of the earth, okay, and they tell us changes in elevation when we're looking at something flat, a piece of paper. So when we're looking at a topographical map, we can kind of see the shape of the land, and the lines tell us how steep versus how flat an area is. So if we had a topographical map of like Saskatchewan, it would have very few or very widely spaced lines, because as you know, you can see from one side of Saskatchewan to the other, okay? At least in some parts. Whereas here in Alberta, okay, and this is in Jasper National Park, okay, we can see that there are mountains, and we can see that there are lots of these little lines here. The closer together the lines are, the steeper that area is, because I think on here, there's a line every 10 or 20 meters of elevation. All right, so every time you see another line, it's a change in elevation of 10 or 20 meters. So the closer together the lines are, the steeper it is. If they're like literally right on top of each other, that's a cliff. Okay, so if we were looking at like this area right here where we can see a whole bunch of lines right on top of one another, that's a cliff. Whereas here, the lines are much more widely spaced, so you could probably walk up that. That's important, because you're going to be planning a route on this map. And if you say, I'm going to walk here, that will be 1 step, and then you'll die. Okay, so you have to kind of pick your route carefully on a topographical map. Does that sort of make sense? Okay, and you can kind of see like any blue squiggly lines, those are creeks or rivers or something like that, and you can see how the lines kind of curve into them because they're usually in a valley. Okay, they usually cut their own kind of valley that they run in. Okay, so you can kind of, it gives you an ability to at least visualize what that area might look like. Okay. So you're going to be given this topographical map with several locations marked on it. These are going to be the locations. You're going to start here, and you're going to go to this spot, cabin 1, and then you're going to go to cabin 2, and then 3, and then 4, and then 5. Okay, so you're going to have to plan your route. You don't have a helicopter, so you can't just go yoink and draw a straight line from one to the other. Okay, it doesn't work that way. Now, in some cases, you're also going to see on the map like a hashed line. That indicates a path. So if there's a path running from one to another, you can walk on the path. If there isn't, then you'll have to bushwhack. Right? That is, blaze your own path, which will make you go a little bit slower. So these are all things that we're going to have to consider when we're planning our route. Okay, so your assignment is first to plan your routes to each of the destinations. When you're doing this, there are several things to consider and, of course, some rules to obey. Some things to consider are that conditions in the mountains can influence the speed at which you travel, especially if you're off trail. For example, you need to look at how steep, that is, how close together the contour lines are. Areas you wish to traverse, okay, how high are you, as altitude plays a factor as well. Okay, also, how many times do you have to cross streams, as this is a slow and often treacherous process. Now, if you are on a path and have to cross a stream, what will there be? A bridge. So you really only have to worry about stream crossings if you are the adventurous type who is bushwhacking. And then a stream crossing is different. Okay, so the rules are as follows. Rule number 1, altitude affects speed. If you've ever gone hiking in the mountains, you know that as you get higher, it gets harder and harder to move. And if you ever watched like people climbing Mount Everest, when they're on their way to the top, they walk like this. And they like literally, they take one step and they have to breathe like 4 or 5 times, right? Because at that altitude, there's so little oxygen that every step is like climbing 3 flights of stairs, okay? And these are people who could run back-to-back marathons at sea level, okay? You don't see out-of-shape people getting to the top of Everest. They're the ones you see on the side of the trail frozen solid for years and years afterwards. Okay, you have to understand that altitude is going to affect how fast you can travel. So if you are on the trail and below the tree line, okay, what I mean by below the tree line is actually in the trees. You can tell if you're below the tree line on the map if you're in the green area. Okay, green in the trees, white above. Okay, so if you are on the trail and below the tree line, you can walk at 1.5 meters per second. If you are on a trail above the tree line, you can only walk at 1.2 meters per second. You are slowed slightly by the decreased oxygen level. The Bushwacker rule. Off-trail speeds are as follows. Below the tree line, 0.75 meters per second. So you slow down by half. Above the tree line, 1.0 meters per second. So altitude plays a factor, but if I'm off the trail above the tree line, I can walk faster. Because, well, you don't have to bushwhack when there's no bush, right? So you can go faster. Okay, and then the last rule is the silly salmon rule. You are not a fish, therefore any stream crossing will add 15 minutes to your total time for the segment if you are off trail. Right? If you're on trail, streams don't matter. If you're off trail and you have to cross a stream, you're going to add 15 minutes to your total time for that crossing. Okay? Everybody with me there? So, second part of this activity is for you to practice your kinematic skills and formulas. Okay, for each day you'll need to measure the total distance traveled. You'll have to get the total displacement, the total time, average speed, and average velocity. So every day on the trail, so from start to 1, that's day 1, you're going to have to calculate or measure the total distance, measure the total displacement, calculate the total time, calculate the average speed, calculate the average velocity. All right, 5 things for each day. Okay. And you are also going to do that for the entire trip. All right, so that day 1, day 2, day 3, day 4, day 5, and the whole trip. Okay. That's why I didn't have you end at the same place you started. Otherwise, that would have been too easy. Okay. Because your displacement would have been, right, and your velocity would have been, and where's the fun in that? I got to make it work. All right. So what I need to see handed in from you guys is, as I said, calculations of distance, speed, displacement, velocity, and time for each day, triangles drawn on the map, as well as the paths or directions you traveled, including vectors. If there is a place where people lose marks, it is right here. I mean, the name of the whole activity is vector activity, and yet I get people who hand in their assignment and they don't have vectors on their velocity, or they don't have vectors on their displacement. Please do that. It'll really affect your mark in a negative way if you don't have vectors in something called vector activity. Okay, so please make sure they're there. Okay. Calculations of total distance, total displacement, total time on trail, average velocity, and average speed for the entire trip. Okay, and you'll hand in your map along with your calculations. Okay, so here's what I would suggest you do. We have these rules that tell us we can walk at different speeds depending on where we are. So if I'm looking at my map, okay, and let's just say that I'm just making up some space because this isn't part of yours. Okay, let's say I'm starting right here, and I need to go to here. Okay, the most logical thing for me to do would be to walk along this trail as long as possible. Agreed? Okay. So I'm going to do that. And I'm going to use green as my 1.5 meter per second indicator. Okay, if I'm below the tree line and on the trail, I can walk at 1.5 meters per second. All right, so once I get to here, then I have to turn and walk up to that. Okay, I'm actually going to modify this just so I can bring in something else. Okay, so let's say I'm going to go just to here along the trail, and then I'm going to walk up to that point. Now I'm off the trail, below the tree line. I can only walk at 0.75, so I'm using red for 0.75 meters per second. Everybody with me so far? Okay, so if I want to measure the total distance, I just have to measure these lines, right? These lines are curvy. Does that present me with a problem? It does. It's hard to measure curvy lines with a straight object. So, what you do is you take something that's not straight, that you can change the shape of. I would suggest your headphone cords or charging cable for your phone will work very well for this. Okay? And so what you do, and it's going to be hard for me because this is vertical and gravity is going to mess with me here. Okay? But if I'm trying to measure the length of this, I just make my string take the shape of my path and then hold it straight, put it on my ruler. Okay? Now I measure how far. Now that's going to be in centimeters. This is a map of something much bigger than 15 centimeters. So here's the other thing you need. On this map, and it says this on the sheet. Okay, the scale for the map is 1 to 50,000. That means that 1 centimeter on the map represents 500 meters in reality. Okay, so I will have measured on my map, okay, these two sections, and I'm going to measure them separately because they're at different speeds. I can add them together to get my total distance for the day. Okay, so that's one of the things I have to report each day is the total distance. The next thing I have to figure out is the total time for the day. Now that's determined by the distances I just measured and how fast I can go on each one of these. G equals D over B. So if I know I could walk however many meters this was, okay, when I measured it, right, I would put that in for D and divide it by the fact that during that part I could walk at 1.5 meters per second. That'll tell me how many seconds I walked that part. Okay, remember that. Okay, I got the same thing here. Okay, I'll have the distance and I'll know that I can walk this at 0.75 meters per second, but I crossed a stream and I crossed a stream. I got to add a half an hour to my time before I do that calculation.
So, any stream crossing at all?
Off trail. Any stream crossing off trail.
And that's 15 minutes no matter which it is?
What do you mean by which?
Or like whatever stream?
Yes, no matter which stream.
Okay.
Because I need to make it difficult. All right, everybody follow what we do there? So that's all the scalar stuff. Okay, that'll get me my times. From there, I'll be able to have total distance and total time and figure out my total or my average speed for the whole day. Okay, from there. So that's the next calculation, is average speed for the whole day. Right, so I'll have now my total distance, my total time, and my average speed. So that's the first three things. Now the last two things are displacement and velocity. So how do I get my displacement on here?
Straight line between the start and end point.
Exactly, straight line between the start and end points. So that line, that arrow, represents my total displacement. I can measure that and give it to magnitude. What will that not help me with?
Direction.
Right. So here's where the vector component part comes in. I'm going to need to draw a triangle for this thing. Now, luckily, on a topographical map, there are grid lines. They tell you north and south and east and west. So all I have to do is make sure that I draw a line that will be my west component and a line that will be my north component. And I just have to make sure that they're parallel to the grid lines on the map. Okay? These ones, I don't have to convert to meters, right? I just need their ratio in order to get the angle. Follow me there. Okay? So when you hand this in, okay, this is what I should see for each day. I should see your path, I should see your displacement, I should see your triangle so that you can get the angle. Okay, so we would have obviously in here that angle, that would be north of west. Okay, so I should see all that drawn on the map, and then I should see all the calculations on a separate sheet for each day. Everybody good with that, what we're doing? Okay, so get together here, let's say groups of between 3 and, let's say 3 and 4. Okay, I mean, if you're gonna get in just a group of 2, it's a lot more work. Okay, I don't wanna see anybody doing this by themselves, it's way too much work for one person. Okay, so let's see, groups of 3 or 4, find a way to break up the work. You can choose. Sometimes people just say, you do day 1, I'll do day 2, or sometimes they're like, you do all the distances, I'll do all the displacements. You figure out how you wanna break up the work so that everybody's doing something. Okay, don't let anybody freeload. Okay. All right. Have at her. If there's questions, let me know.
Yes. What?